Why does the most advanced bomber in the world have no tail? That's not just a design quirk. It's a clue. A clue to how the B-2 Spirit became the world's most invisible warplane. If you look at it from behind, something's missing. No vertical fin, no rudder, no tail like you'd see on a normal fighter or jetliner. And that missing piece, it's not an accident. It's the whole point. Because every straight edge on a plane reflects radar. And if you're flying deep into enemy territory like Moscow or Beijing, you don't want to be seen at all. The B-2 isn't shaped for speed. It's shaped for silence on radar, on thermal scans, even to the human eye. But here's the twist. Removing the tail made it nearly impossible to fly. So how did they solve that? And why haven't other countries built anything like it? The B-2 Spirit doesn't look like any other bomber in the world. No tail, no sharp angles, just a smooth, flat triangle cutting through the sky like a shadow. It entered service in 1997, but traces its roots back to the Cold War. Built by Northrop Grumman, it was designed to fly into the heart of Soviet airspace without ever being seen. The U.S. Air Force wanted a plane that could deliver nuclear weapons without being detected by radar, infrared, or satellite. That goal came with a price tag, over $2 billion per aircraft. Only 21 were ever built, and today, just 20 remain operational. The B-2 is so expensive and complex to maintain. It's often kept in climate-controlled hangars at White-Titman Air Force Base in Missouri. But the cost isn't what makes the B-2 special, its capability. The Spirit can carry both conventional and nuclear bombs. It can fly over 6,000 nautical miles without refueling and more than 10,000 with a tanker. Its wingspan is huge, 52 m wide, yet it's eerily quiet in the air. And thanks to its stealth profile, it can get within range of high-value enemy targets like hardened bunkers or mobile missile launchers without setting off radar alarms. But here's what sets it apart even more. Only the United States has this plane. No other country on Earth has ever built anything quite like it. And the biggest visual clue that you're looking at something different is that missing tail. Because the B-2 shape doesn't follow normal flight rules. It was built with one goal in mind. Don't get seen. So to understand why the tail had to go, we need to understand what a tail actually does and why stealth aircraft want nothing to do with one. Most airplanes have a tail. It's not optional. It's how you keep the plane stable. Those vertical fins and horizontal stabilizers at the back help steer the aircraft, keep it level, and stop it from spinning out of control. Think of it like the feathers on an arrow. Without them, flight becomes unpredictable. But on the B-2, those stabilizing surfaces are gone, and that's entirely intentional. And why? Radar. Traditional tails create sharp edges and upright surfaces. These bounce radar signals right back to the source, lighting up the aircraft like a flare on enemy screens. The B-2's main mission is to sneak into hostile airspace without being detected. And anything that reflects radar, especially vertical surfaces, is a liability. So the designers at Northrop Grumman took a radical approach. They eliminated the tail completely and built the aircraft as a flying wing. The flying wing is exactly what it sounds like, just the wing. No fuselage sticking out, no tail in the back, just one smooth, continuous surface from end to end. The entire aircraft is shaped to deflect radar away in every direction, not bounce it back. The idea wasn't new. Back in the 1940s, Jack Northrop, yes, the same Northrop, experimented with tailless bombers like the YB-35 and the YB-49. They looked futuristic, but the technology to control them didn't exist back then. Without onboard computers, they were too unstable to fly safely. Fast forward 40 years, and digital flight systems finally caught up with the dream. The B-2's tailless shape isn't just about hiding from radar. It also helps to reduce drag, which allows the bomber to stay airborne longer. That smooth surface cuts through the air without the turbulence caused by tail fins. The aircraft's engine intakes are buried deep inside the wing. Even the exhaust is hidden, shielded to reduce its heat signature and avoid infrared detection. Every angle, curve, and surface on the B-2 was designed with stealth in mind. But removing the tail came at a cost. The plane became aerodynamically unstable. In fact, without constant adjustments, it would tumble out of the sky. So, how does the B-2 actually stay in the air? That's where the next layer of genius comes in. Software that thinks faster than a pilot ever could. Here's the truth. Without computers, the B-2 wouldn't fly at all. The tailless flying wing design is naturally unstable. It doesn't want to fly straight. It doesn't want to stay level. Most pilots wouldn't stand a chance trying to manually control it, especially at high speeds and high altitudes. That's where fly-by-wire comes in. Fly-by-wire means the pilot isn't directly controlling the aircraft's surfaces. Instead, every movement of the joystick or rudder pedal goes into a flight computer. That computer then calculates what the plane needs to do and sends signals to tiny motors that adjust control surfaces across the wing. We're talking about hundreds of tiny corrections every second. Pitched too far up, the computer tweaks the elevons, combined elevator and aileron surfaces, to nudge it back. Yaw to the left, it might open a spoiler on the right wing to slow it and slightly realign the heading. The pilot still gives input, but the computer does all the hard math instantly. And because the B-2 has no vertical stabilizers, it has to get creative with how it turns and balances. It uses something called split rudders, which are panels on the trailing edge of the wing that open up like clamshells. They create drag on one side of the aircraft, helping it pivot or correct yaw without needing a tail fin. There are also spoilers which pop up to disrupt airflow and slow one wing during a turn, giving the aircraft controlled rotation. Even the thrust from the engines is part of the steering. If more power is pushed through the left engine than the right, it subtly helps the bomber veer to the right, like paddling a canoe harder on one side. All of this is handled by the aircraft's central flight computer using sensors, gyroscopes, and algorithms that constantly predict and correct instability before the pilot even notices something's off. It's not just smart, it's essential. Without this system, even a small turbulence bump or a crosswind could send the aircraft into an uncontrollable roll. But with it, the B-2 glides smoothly, even gracefully across the sky. Its biggest strength is its radar evasion. Because there's no vertical stabilizer and no sharp angles, radar waves don't bounce back to the source. Instead, they scatter in other directions. That makes the B-2 nearly invisible to most conventional radars. Its radar cross-section is often compared to that of a large bird or even a small bearing. Not because it's tiny, but because it looks that way on a radar screen. Even advanced radar stations may only pick up a vague blip, and by then it's probably too late. Then there's altitude. The B-2 flies high, typically above 50,000 feet. From that height, it can observe and strike without ever coming close to enemy defenses. And because it doesn't need to dodge radar by flying low through valleys or hugging terrain, it can conserve fuel, fly straighter, and stay airborne longer. Then there's the range. On a single tank of fuel, the B-2 can travel more than 6,000 nautical miles. Add mid-air refueling, and it can circle the globe. That's why the US can launch a mission from Missouri, drop bombs over the Middle East, and return without ever landing abroad. The aircraft can also carry 40,000 pounds of weapons, both conventional and nuclear. Its bomb bay is configured to handle smart bombs, bunker busters, and even stealthy cruise missiles. In a real-world mission, the B-2 doesn't just sneak in. It hits the target and disappears again, sometimes before enemy commanders even realize something was coming. All of this without firing a shot from close range. No dogfights, no flares, just precision from a distance. And that ability to deliver overwhelming force without detection. That's what makes the B-2 more than just a bomber. It's a ghost with teeth. But for all its stealth and precision, the B-2 isn't perfect. Let's start with the obvious. It's extremely hard to fly without computers. The aircraft is aerodynamically unstable by nature. If the flight control system goes down, the plane becomes almost impossible to control. There's no manual backup. It's software or nothing. Then there's the cost. Each B-2 cost around $2.1 billion to build, more than most Navy destroyers. But that's just the beginning. Maintaining a B-2 is like keeping a supercar in spacesuit-worthy condition. Every flight demands hours of maintenance. The stealth coating, called RAM, or radar absorbent material, has to be checked and often reapplied. Even a small crack or panel misalignment can give the aircraft a larger radar signature. It also needs special climate control hangars. Why? Because humidity and dust can damage the stealth surface. The paint isn't just paint. It's part of the invisibility. And then there's the maneuverability. The B-2 isn't fast. It cruises at subsonic speeds around 630 miles per hour or 10 km per hour. That's slower than most fighter jets and even slower than the older Cold War bombers like the B-1 Lancer. It also doesn't turn sharply. There's no air combat agility here. It's made to fly straight, fly high and far. And then finally, visibility. In daytime operations against a clear sky, the B-2 can be visually spotted. It's not totally invisible to the naked eye, and once detected, it has no onboard defensive weapons, no guns, no missiles, just countermeasures and evasive maneuvers. So, while it's nearly untouchable in a stealth mission, it's vulnerable if caught off guard or flying alone in the wrong airspace. That's why missions are carefully planned, often at night, with full support from tankers, satellites, and reconnaissance assets. The B-2's strength is invisibility, but it comes at a high price and with high stakes. The B-2 Spirit won't fly forever either, but its successor is already in the sky, the B-21 Raider. At first glance, the B-21 looks almost identical. Same flying wing, same smooth curves, no tail. But under the surface, it's a new generation. Developed by Northrop Grumman, the B-21 was officially unveiled in 2022. It's designed to be smaller, cheaper, and easier to maintain than the B-2. While the B-2 required custom parts and climate-controlled hangars, the B-21 uses modular systems and coatings that can be replaced faster and cheaper. The B-21 is also built with China and Russia in mind, able to strike deep targets in high-threat zones with improved survivability. Flight testing began in 2023, and the U.S. Air Force plans to buy at least 100 Raiders. That's 5 times more than the total number of B-2s ever made. But even as the Raider takes flight, its design owes everything to the lessons of the B-2. Same ghost-like profile, same flying wing, and still no tail. Because in the future of warfare, being seen is the biggest weakness of all. So why does the B-2 bomber have no tail? Because it was never meant to be seen. The tail of an aircraft reflects radar. It gives the enemy a place to lock onto, a place to aim, and a place to shoot. The B-2 doesn't give you that chance. Its shape bends radar waves. Its surface absorbs them. Its engines are buried deep, and its entire flight path is designed not to impress, but to disappear. What it lacks in agility, or speed, it makes up for with reach and silence. It doesn't need to fly fast. It just needs to fly unseen. And it does. For over 30 years, it's been the only aircraft in the world that can fly straight into defended airspace and drop precision bombs without ever being tracked. And now with the B-21 Raider on the way, that legacy continues with no tail and even fewer traces. But now we want to hear from you. Do you think other countries will ever catch up and build something to match the B-2? Or is stealth this advanced just too far ahead? Let us know in the comments. And if you want to go a step further and support the channel directly, join the fleet. You get loyalty badges, priority responses, and you help us bring more true aviation and maritime stories to the surface. Click join on our channel page and get on board. Thanks for watching. Stay stealthy.